डॉक्टर गुलाब फलारी, एसोसिएट प्रोफेसर, डिपार्टमेंट ऑफ इकोनॉमिक्स, जे कॉलेज आ रहा। आज आप लोग को हम आइसोक्वांट्स और इक्वल प्रोडक्ट कर्व, समुत्पाद वक्र क्या है, इट्स कंसेप्ट एंड इट्स कैरेक्टरिस्टिक्स के बारे में बतलाएंगे। The law of returns to scale can be explained through production function and isoquant curve technique. But the most popular and simple tool of analysis is isoquant curve technique. The term isoquant has been derived from the Greek word iso, meaning equal, and Latin word quantus, meaning quantity. Then the isoquant curve is also known as equal product curve or प्रोडक्शन इंडिफरेंस कर्व। ऐसी स्थिति में आइसो प्रोडक्ट कर्व को इक्वल प्रोडक्ट कर्व या प्रोडक्शन इंडिफरेंस कर्व भी कहते हैं। एन आइसोक्वांट कर्व कैन बी डिफाइंड एज द लोकस ऑफ पॉइंट्स representing various combination of two inputs, say capital and labor. For the sake of simplicity, here we assume that the production is the result of capital and labor. It is the same output here. An isoquant curve is analogous to an indifference curve with 2 points of distinction. First, an indifference curve is made of two consumer goods, while an isoquant curve is constructed of two producer goods, say labor and capital. And second, an indifference curve assumes a level of satisfaction for the consumer, whereas an isoquant measures output of a commodity. Now the concept of equal product curve can easily be understood from the table given below. Here combination A, B, C, D, E, factor X, factor Y, factor X 1, 2, 3, 4, 5, factor Y 12, 8, 5, 3, 2. To begin with the combination A represent 1 unit of factor of X and 12 units of factor Y, produces a given quantity, say 40 units of goods of a product, and all the combinations in the table are assumed to yield the same level of output, that is, say 40 units of the product. And if we plot all these combinations on a graph paper, we shall get a continuous and smooth curve called isoproduct curve, on which they are represented the various combinations, say A, B, C, D, and E of the table. Now on the basis of these tables, when we plot the data on a graph paper, we obtain isoquant curve like this one. On OX axis we measure the factor of X, on OY axis we measure the Y. And the combination A, B, C, D, E here, A, B, C, D, E. And when we join this point we get isoproduct curve slope downward from left to right. Now properties of isoquants are explained below in terms of input and output. First properties or characteristics of isoquants are isoquants have a negative slope. This is the slope of the isoquant, negative slope. An isoquant has a negative slope in the economic region here. This is the economic region and in the economic range of isoquant. Economic region is also known as the product maximizing region. The negative slope of the isoquant implies substitutability between the inputs here. It means that if one of the inputs is reduced, the other input has to be increased so that the total output remains unaffected, that is 40 units of output. Now second properties of isoquant are convex to the point of origin. Now convexity of isoquant implies two things. First, substitution between the two inputs and diminishing marginal rate of technical substitution denoted by MRTS between the input in the economic region. And hence MRTS is defined as minus delta K by delta L equal to slope of the isoquant. In plain words, MRTS is the rate at which a marginal unit of labor can be substituted. A marginal unit of capital moving downward on the isoquant here without affecting the total output. Here the output is constant, that is 40 units. So this rate is indicated by the slope of the isoquant. The slope of the isoquant is negative. As mentioned in the table, in this table, various combination of factors, say it is X and Y, yield output equal to 40 units of the product. From the comparison of combinations A and B, it will become clear that 4 units of factor Y can be replaced by 1 unit of factor X without any change in output. And table here is MRTS, combination A, B, C, D, factor X 1, 2, 3, 4, 5, factor Y 12, 8, 5, 3, 2. MRTS, marginal rate of technical substitution of X for Y, here is 4 is to 1, 3 is to 1, 2 is to 1, 1. Therefore, 4 is to 1 is the marginal rate of technical substitution at this stage. Now, by comparing combinations of B and C, it will be found that 3 units of factor Y can be replaced by 1 unit of factor X. without any loss of output. Therefore, here MRTS is similarly MRTS between C and D is this one, and D and E is 1. Algebraically, it can be stated that MRTS equal to delta X by delta Y. But delta X by delta Y shows the slope of the curve. Slope is negative. Therefore, MRTS is the slope of the isoproduct curve at a given point and can there be found by the tangent of the angle. The marginal rate of technical substitution can well be explained through this diagram. In the figure, MRTS at point R at this point will be equal to the slope of the tangent DE. Slope of the tangent DE is equal to OD by DE. OD by D. Hence, MRTS at point R will be equal to OD by DE. OD by DE. MRTS at point S at this point of the isoproduct curve will be OG by OH. Now, marginal rate of substitution of X is increased relative to the quantity of Y. This is known as the law of diminishing marginal rate of technical substitution. Now, another concept is the relative change in the factor proportion. As a consequence of relative change in the MRTS is known as elasticity of substitution between factors. Now the third property is isoquants are non-intersective. It means that two isoquants can never intersect each other. The intersection or tangency between any two isoquants implies that at a given quantity of a commodity can be produced with a smaller as well as a larger input combination. This is unattainable so long as marginal productivity of inputs is greater than 0, and this point can be proved graphically here. Intersecting isoquants here at 2 equal product curve intersect each other. First equal product curve Q1 equal to 100, Q2 equal to, and intersect at this point. In the above figure, two isoquants intersect each other at point M. This is the point M. Consider two other points, say point J, on isoquant mark 1 equal to 100, and point K at this point K here, an isoquant mark Q2 equal to 200, such that point K and J fall on a vertical line K and 2 denoting the same amount of labor, that is OL2, but different units of capital, say KL2. Units of capital at point K, and JL2 units of capital at point J. Point M is a common to both the isoquant. This point is common to both the isoquant. Say it is Q1 equal to 100 and Q2 equal to 200. On the isoquant Q1 equal to 100, factor combination at point M and J yield 100 units of output, and on the isoquant Q2 equal to 200, factor combination at M and K yield 200 units of output. Since point M is common here to both the isoquants, it follows that input combinations at J and K are equal in terms of output. This implies that in terms of output, OL2, that is labor, plus JL2, that is capital, equal to OL2 labor plus KL2 capital. Since OL2 is common to both the sides, it means JL2 of capital or equal to KL2 of capital. But it can be seen in figure JL2 less than KL2, but the intersection of the two isoquants means that JL2 and KL2 are equal in terms of output, and this is wrong. So, two isoquants can never intersect each other. That's all.